Hi, I'm John Paul Raj, and in this video, we continue to solve question number 2 from paper 3, May 2025, time zone 2 for IB Mathematics Applications and Interpretations. Let's get going. Point A, which is also on the equator, has position vector A bar. Remember, you have to read it as A bar, okay? And write it as A bar. 600 as shown in the following diagram, P, N, and A. So this is point A, which is given here. And what are we given? That P, N, and A are P, N, and A, and the arcs connecting them form a spherical triangle. The angle at vertex A is defined as the angle between the vectors A cross P and A cross N. We want to find the vector in part 1 of C. We want to find the vector A cross P. Again, we are going to use the calculator. We've already defined that, okay? So, and it's just 2 points, so that's all right. So I'm just going to, yeah, we have got space here. So this is question 2, C, part 1. I'm going to write down using GDC. And we've already defined P, all right? So A has to be defined. And so I'm going to go to the calculator and show you quickly that we have defined P was defined. Can you see that? And so the same way, we're going to go ahead and define A now, right? So A is going to be defined in the same way as a vector. We're going to go through menu. Actually, last time I edited and edit the vector, but I'm just going to show the whole thing again, right? So you don't have to define this vector. You have to define it on a matrix, okay? So matrix as a column matrix, so 3 rows and 1 column. And that's how you'll define. Okay, what I meant by editing is that go and check out that video, okay, how I did that. Once it's defined, you can always recall a vector and edit it off and label it in a new way. You could do that way, or you could do this way, okay? So this is 600, I believe. 600, and then hit enter, and it's done. Now we're finding the cross product, right? It says finding the cross product, A cross P. And then we have to find the angle between the two vectors A cross P and P cross A, which they have said in part 2, show that it is 90 degrees. Okay, it says show that the angle at the vertex is the angle between those two vectors A cross P and A cross N, and that is what we want to show, that it is 90 degrees. Again, we can use the idea of the dot product being 0, angle must be 90 degrees. We could use that approach, okay? So let's just head back to the calculator and we say that we want the cross product, right? A cross P. And here the order is important, okay? A cross P. So I'm just going to come here, vectors, cross product. And so A, comma, P. A cross P is the same thing as, okay? That's the syntax for cross product, and hit enter, and I'll get it as a vector, 0, negative 36, 0. We need to write it down properly, but we need to write down what we've entered and how we've used the calculator, okay? So coming back here, this is using GDC. We'll show that we've defined again, all right? So A is defined as the vector 600, and P is defined as the vector 006, okay? And we want to find out A cross P, and then we can say therefore A cross P is on the calculator is defined as cross. So you can tell the examiner that that was the syntax I used, right? And that gave me the vector 0, negative 36, and 0. Okay, that is A cross P. That's for part 1. Show that the angle between this, show that the angle of the vertex A, okay, the way they have defined. So I'm just going to go and write it down. Angle at vertex A, and as they've defined is the angle that, between the two vectors A cross P and A cross N, is angle between A cross P and A cross N. I think A cross N, and oh, we need to write the bars. I was the one who said that and I didn't write that. See that? Oh my God. Please don't be judgmental, okay? Make sure that when you're writing it as vector, you need to put that bar. I kept saying that and I did not write that. Yeah, my God. Okay, please, I apologize, all right? So first let's find out A cross N, okay? A cross N, A bar cross N bar using GDC, okay, is, let's go back to the calculator, the same way. Okay, now you can just go and find and change that. Okay, can you see that? I can just change that. N was already defined, so it shows as bold. N was already defined, and we can bring that up. That's 0036. Okay, so that's what I meant by editing it, you know, so it'll save time. You can recall it, and that's also the beauty of defining things. Okay, defining things and keeping them on the same page. 0036 is the vector A bar cross N bar. You know, the more I say A bar cross N bar, then I know that I must write A bar cross N bar. So this is 0036. Then we can write down angle between A bar cross P bar and therefore, okay, and A bar cross N bar is given by, you can say, cos of the angle, if you want to call that theta, all right, is equal to the dot product between those two vectors, A bar cross P bar dot A bar cross N bar. Remember, the cross product results in a new vector. Okay, so the cross product is a vector divided by the magnitude of those two vectors, A bar cross P bar and the A bar cross N bar vector. Okay, so that's the formula you're going to use. 36 0 dot 0036, I believe. The magnitude of 36 0, magnitude of 0036. Okay, that's a lot better magnitude. Okay, using GDC now, then that is equivalent to, let's just jump to the calculator. What do we need to find? First, we want to find the dot product of those two vectors. Okay, so we can just go to the menu and vector and magnitude, come down here and go to dot product. Can you see that? And now you can reference those two vectors. Okay, so I can just go this two vectors, this vector, I can bring that thing down, dot product this, comma, that one. Okay, so that's the syntax. Okay, dot product with those two vectors is equal to 0. That's all, right? So using GDC, we can just say that, I think that's what we want to show, that is 90 degrees, right? So we can say using GDC, cos of theta is just 0. Cos of theta is 0, which means that the angle, therefore, theta must be equal to pi by 2 radians, or radians, which is the same thing as 90 degrees. What do they ask us in degrees or radians? I don't know. Let me just check quickly. They have asked us, show that the angle at vertex A in the spherical triangle is 90 degrees. So that's good. We have shown that cos of the angle is 0, which means the angle between these two vectors, A cross P and A cross N, which is the same thing as the angle at the vertex A for that spherical triangle, is 90 degrees. Cool. Let's go to D part, and before that there's some instructions given here. Moscow M has position vector M bar as 0, 6 cos theta, 6 sin theta, as shown in the diagram. That's Moscow M there. Okay, the shortest distance between 2 points on the sphere lies along an arc of a circle on the sphere with center O. In this model, the shortest distance from Moscow to Nairobi is 6,000. Okay, 6,000 kilometers. Looks like the arc length. Show that theta is equal to 57.3 degrees, correct, to 3SF. Okay, so we're going to use the angle here, question 2D, and we want to show that the angle is 57.3. So basically, the language is shortest distance from Moscow to Nairobi, Moscow to Nairobi is the angle, which is what we want to find out, the theta over 360 times 2 times pi, and the radius, which is 6, am I right? 6,000 was what we had earlier said in the question. I think we read it. Let me just check that quickly. Let me just quickly check that. Yeah, 6,000 kilometers. There, you can see that. All right. So having said that, it's always a good idea to check again and again. Okay. This is 6,000, but we're writing this as 6. Okay. And that is theta O 360 times 2 and times pi times 6. So what is this going to come out to? So the 6's are gone out. 6 and 6 will cancel. That's 1 here, by the way. So this is the angle theta is just 360 over 2 pi. That's your theta. Okay. So let's just work this on the calculator. 360 over 2 pi. What are we going to get? So I'm just going to get this thing down here. 360 over 2 pi. 2 times pi. I'll just bring this thing down here. And what am I going to get if I hit enter? I'm going to get 57.3, as they exactly wanted that same thing, right? So this is the same thing as 57.3 degrees. I think that's the value that they had said show that. We've done that bit. Now, what's the next one? Bogotá is west of Nairobi and has position vector OB bar is 6 sine 120 and 6 cosine of 120 and 0. Find the shortest distance from Bogotá to Moscow on the sphere. Again, we're going to use the formula for the arc length, okay, because that's how it's defined. Okay, so we are finding that. But first, we need to find the angle between ON and OB. We don't know where exactly, not necessarily on the equator, okay, but if this is B, then OB and ON. So this is the angle, that angle we need, BON, right? So we can use the formula again, okay? The dot product formula can be used. This particular formula, that is, okay, this cos theta that I had mentioned earlier on, this particular formula can be used to find the angle, okay? And we're looking at OB and ON. 2E, is it 2E? Let's just continue here. 0, question 2E. So we'll write down angle between OB and ON. That's what the first thing we want to find out. And so we can say cos of BON, okay? BON, that's how it has to be labeled, cos of BON. Same kind of formula that we did earlier on, okay? So this is going to be equal to OB bar dot ON bar divided by the magnitude, okay? And here we can substitute the values. 0. OB bar is 6 sine 120 degrees. So go ahead and do that quickly. 6 sine 120, 6 cosine 120, and it's a 0. And I think this is 0, 6, 0. Let me just double check that quickly. 6 sine 120, 6 cosine, and 0. And the ON bar 060. Yeah, I got that right. And let's just copy that clearly. This is to be divided by the magnitude of these two vectors. 6 sine 120, 6 cosine 120, 0, and the magnitude of 0, 6, and 0, okay? The magnitude, put that as a vector. Okay, there you go. I think this should be good. Using GDC. So let's go ahead and define that. And this time again, we'll make use of a vector that's already there. Okay, so maybe which vector? Okay, let's pick this one and let's just make the changes here. Okay, B bar is going to be defined as 6 sine of 120, 6 times sine of 120. Okay, 120. Why am I doing 129 again and again? All right, here we go. This should be 6 times cos of 120 again, and then it's a 0. Okay, got that thing down. All right, so we want the dot product in the numerator. Menu, and I go to vector dot product. I want the dot product of OB bar. This is OB bar, right? This is OB bar, comma, ON bar. And can I just write n? What will happen? Yeah, there you go. Good. So that's negative 18. All right. So this is the numerator. So let me just write that thing down. This is negative 18 divided by the magnitude of the two. Now this is interesting. Okay. That's why I want to do it separately rather than put it together. We want to find the magnitude of the two vectors. How do you find the magnitude? Is you go through the same, but the word is norm. Okay. So it's the norm of a vector. So norm is what you need to use to find the magnitude of a certain vector. So norm of the vector OB bar, norm of this vector, okay, is actually 6. Okay, that's the magnitude. You could have even said norm of, okay, without that vector, I could have just put B there because that's how we've defined it, right? Norm of, say, B, and you'd have got 6. So in the same way, if I just say norm of N, right? Yeah, we need that one. And that's 6 again, okay? So the magnitude of the two vectors is 6, that's clear, but just showing you on the calculator, how do you find the magnitude using that option norm, okay? So coming back here, this is basically just 6 times 6, okay? So that's just negative 18 over 36. That's just a negative half, okay? So this is the cos of the angle BON, right? So let's just continue here. Cos of BON is a negative half. To be on the safe side, I'd say go and use the calculator again and find cos inverse of a negative half. See what the calculator says. So let's just come back. Okay, a little bit of trig. Cos inverse of a negative half. So this time again, use this one, 1 and 2, and we are going to get it as 120 degrees. There you go. All right, so this is 120 degrees. I'm just going to come back to my working here, and I'd say this angle is 120. This is just part of the answer, or just the first part of the answer. We wanted this angle. Now we will find the arc length. Remember, that was the main thing. Okay, so where are we going with this? Shortest distance. So I'm just going to write down required distance, okay, the shortest distance. So it's theta over 360. That's the theta we're going to use. And let's just make sure we write down degrees. Okay, then I'll just write down required distance. Required distance then is that theta over 360 times 2 times pi times the r, which is 6, okay? Remember, every unit is 1,000, okay? And I'm just going to enter this thing as it is on the calculator. Coming back to the calculator, we can write it as 120 over 360. And let's just get times 2 times pi and times r is 6. I'm going to write it as, and we get 4 pi, which is actually 4,000 pi kilometers, okay? So let's come back here, and this is going to be 4,000 pi kilometers. Don't forget the units. Good. That is, which part have we completed? We completed the E part. One more part. So it might get a little long, but don't worry, we'll complete this. Yeah, it is going to get a little long. The bearing from B to M is defined as angle at vertex B in the spherical triangle B, M, and P. That's containing B, M, and P. So it should be the angle between B cross P and B cross M. Okay, so that's what I think we're supposed to find out. So this is B cross P they've given to us. We need B cross M then, okay, and then to find the angle between them. So use the method from part C. That's the reference, okay? So we need first B cross M. B is given to us. M is also given here. That's M, okay? So let's just first find out B cross M, and then we can use the angle between the two. Again, the same formula. Again, can you see that? 6 points. Be careful how you write this. 2F. 2F, where am I? Where am I? Okay, let's just do it here. This is 2F. All right, so B bar cross M bar. B bar cross M bar. I hope I got the letters right. B bar cross M bar is what we want to find out. Okay, using GDC. Using GDC. And always when you write, you have to make sure how, you have to tell them how you've written. Okay, so using GDC, let them know that you defined it. Okay, the definition, how you define, and what is it, 6 sine 120. It's already defined, I know, but it's better to let the examiner know this is how you've gone about doing it. Okay, so 6 sine 120, 6 cosine 120, so that they know what that using GDC means. 6 points, man. It's better to do all that. B, and then M bar is defined as M, let me just check quickly what that M is. Oh, 0, 6 cos theta, 6 sine theta. Okay, 0, 6 cos theta. Oh, sorry, 6 cos. The theta is what we found out here, right? 57.3, that's what we need to write down. Okay, yeah, 57.3. 6, yeah, 57. Is it the same theta? Yeah, it is the same theta. So we got to write that 6 cos of 57.3. Okay, just make sure that's how it is to be written. So 6 cos of 57.3 and 6 sine of 57.3. I don't think this was defined, so good. And then we can just say B bar cross M bar. The syntax is cross P B bar M bar. Okay, that means you're telling the examiner this is how I've used the GDC. All right, let's just jump over and let's just first define M, because that is not defined here. Okay, control, and then I just go and why don't I just take a already defined vector. Bring that thing down and then make sure we have changed this first to M, and here this is 0, I believe, and here I'm going to change this to 57.3. 57.3. Here we are going to change this to 6 times sine of 57.3. Okay, so we've defined M. There you go. And now let's find the cross product, B cross M, and here we are, cross product of B comma M. And that's a great value. Okay, let's just copy that thing down as it is. Here's a vector. Okay, and I have negative 18. This is the exact value, right? Before I copy it down, let's just get the decimal values. Okay, the approximate value, that is. Okay, so I just come back, and so if I hit Control Enter, what do I get? There you go. Let's just get that part. Okay, so this is better. I just write it as negative 15.1, negative 26.2, and 16.8. Okay, so that you can see what I've written. Okay, I didn't want to put that exact values there, I just put the vector values here. Now then we can say that required angle, if you don't want to write the whole phrase, required angle. Okay, therefore required angle is angle between B bar cross P bar and B bar cross M bar. Okay, just to let them know what is going on. Okay, how you use the part C. So that would be the cos inverse of 36 cos 120 negative 36 sine of 120 and a 0 dot, and what do I have, 15, negative 15.1, negative 26.2 and 16.8. It's important to put all these values down. Okay, and then the magnitude of these two vectors. So you know, even if something went wrong in the calculations or entering into the calculator, the examiner will understand what's going on. The magnitude of this vector times the magnitude of negative 15.1, negative 26.2, and 16.8. Put that thing, whole thing under the bracket. This part is important, that you've shown the substitution into the formula. Then we can say using GDC. Have we said that already before? Yeah, now we can say using GDC. Using GDC. All right. Now, what I always do is that I do numerator separately and denominator separately. Okay. So the numerator requires us to find the dot product. Okay, the dot product of the two. And there's also that norm thing. I've already shown you how to find the norm. Let's just jump over to the calculator, and we need this, right? What should I call this vector? I don't know. Let's just call it some other letter. Let's say K, right? I'm just going to call it K for that B bar cross P bar. Okay, I need to define that vector. So let's just come here. I'm just going to call it K. K. Okay, delete these entries. Why does this all go off? Undo. Can I hit undo? Yeah, there you go. Control Z brings the undo option. Okay, so maybe I should just do one at a time, huh? Okay, there you go. Just be careful how you're using this thing. You can see, you know, even I got, especially if you're editing. If you're just entering it as it is, that's a different story. Okay, so I need to enter the vector 36 times cos of 120, and then I have a negative 36 times sine of 120, and then this is 0. Okay, this is my k. Now I want the dot product of this one with that 15.1, this other vector that we have. So let's just go, no, not statistics, vector dot product. I want the dot product. This is the numerator. Okay, the dot product of this guy, this vector, comma, this vector. All right, these two vectors, and I hit enter, and that is a huge number, but let's just bring that down and say control enter. Okay, so we're just going to write it as 1.09, and you know, I've already showed you how to write that in, how to translate the idea, but let me just check what the, so this 1.09 E3, I've also already explained in the earlier video what that E3, how it has to be translated, and you know, you can bring down the digits and say that is clearly 1090 if that's kind of confusing to you. So using GDC, I can write down, I can bring it back and say, okay, the numerator, remember this is cos inverse, the numerator is basically 1090. Okay, I'm just going to write down there 3SF, good enough, but we are going to use all the digits, okay, because then you'll get more accuracy. Okay, let's just jump back because we need to find the norm of the two vectors. Okay, the norm of the two vectors. When there's too much happening in the calculator, be very careful, so I go to menu, vector, and I'm going to find norm. Remember, that's how we are going to find the magnitude of the two vectors. So this is obviously here. There you can see that option, norm of the vector. We call it k, I believe. K is the vector 36. Okay, so that I'm going to write 36. Then we want to find the norm of the other vector. We haven't labeled it. I'm talking about this particular vector. Okay, this one we haven't labeled it. Maybe it's a good idea to label it. Shall we do that quickly? Okay, so k, let's just call that maybe, I don't know, t. T is defined as the vector, this vector, okay. If I just hit enter, and yeah, that's in the exact form, by the way, and that's okay, it's already defined. So if I bring this thing down, I'll show you what I mean by, okay, there you go. All right, that's the vector. So t is defined. Now we can find the norm. Okay, and I just go and bring the syntax for norm, which is already there. I just say norm of t and hit control enter. See what I get. I get 34.7. That's good. 34.7. Enter these values. You know what? This is what you want to show. You don't want to put the whole thing. The whole drama is going on in the calculator. Okay, it was quite dramatic, but make sure you put down the numbers here so that the examiner understands that you substitute the correct values, and you already said that you have used GDC. You use the GDC to do all that magic. Okay, and then let's ask the GDC to do one more magic at the last for you, which is cos inverse. So come back here and cos inverse of. Now put down this expression as you see. Okay, as you see. So I want this expression, this entire expression, I'm going to enter it as it is. Okay, so it's 1090, and here I got 36 times 34.7. All right, and then hit control enter. What do I get? I get that value is 29.2. 29.2. Come back and we say that is 29.2. 29.2. I think that is all that we need to find out. Let me just check. Let's say use a method to find the bearing from Bogotá to Moscow. Bearing, right? Bearing should be reported with a 0. I've already explained that before. So either you can write this way, or I think, you know, if you want to be accurate, so you can just say 0 to 9 degrees. That's good enough. Okay, so required angle. Okay, so you can just say 0 to 9 is the bearing in the context of the question, that is the required bearing is good enough. if you are running out of time, required is a good word to use in the exam. So that completes this question and this paper. If you found this video useful, please make sure that you like this video, share this video with a friend, and subscribe to my channel. If you visit my channel, there are several other videos on my channel. Do check them out. And if there's any particular question, any particular topic, any particular concept that you'd like explained, do mention that in the comments and I'll make a video for you.